Chemistry. Elements. Elements are pure substances that cannot be
broken down
chemically into simpler kinds of matter. Here's the periodic table of the elements. You don't need to know a lot about this for me. You just need to know the most common ones that are in living things. So it's carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Did I get them all? Yep, that's it. So those are the ones that you need to know. There are other elements that are important, like calcium, for example. Whoops, calcium's really important. The one that I just crossed out, potassium, that's really important too. But the ones that I want you to memorize are those first 6, because those are the ones that are in the big macromolecules that we're going to study. You need to know the 6 major elements in living things.
Things you just mentioned?
Yep. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Different animals might have a little bit more of another element, like
Calcium.
Like calcium, but these are the big ones that make the big molecules, like carbohydrates.
Also, like plants don't have a lot of calcium.
Right,
So
right.
that's why it's not in there.
And also these are the ones that make up the big macromolecules, which are carbohydrates, proteins, lipids, and nucleic acids, which we'll talk about next. So here's a way for you to remember these chomps. Some people say chanspa, either way, as long as you memorize that.
Sure.
So an MCAS question might say something like, what are the elements that you'll find in a plant or something like that? And it's going to be some combination of these. Atoms. An atom is the smallest particle of an element that has all the properties of that element. So 1, 2, 3, 4, 5. It says there's 6 protons. There must be one on the other side. If it's 6 protons, then that's carbon, because that defines this element as carbon. If it didn't have,
if there's 1, then it's hydrogen.
Good. And if you lose 6 protons, oh wait a minute, sorry, I counted the wrong, oh man. So 1, 2, 3, 4, the positive ones are the protons. That was really embarrassing. The positively charged ones are the protons. So
it's okay. Everyone makes mistakes.
Yeah. So the protons are positive, which I'm going to give to you in a minute. And so 1, 2, 3, 4, the others are behind it. There are going to be 6 altogether. That's carbon. If you lose one, you're a boron. If you have an extra one and you have 6 protons, you're nitrogen. If you look at the negatives, 1, 2, 3, 4, 5, 6, if you have 6 protons, you're going to have 6 electrons in a neutral atom. And so you are going to guess your number of electrons based on the number of protons. So an atom of carbon is the smallest particle of carbon that is still carbon. If you took it apart, you'd have just protons, neutrons, and electrons. If you lost one of your protons, then again, it wouldn't be carbon, it would be boron.
If you gained an electron, wouldn't it be nuclear or something?
It would be if you have a different number of protons, it wouldn't be carbon anymore. So yeah, during a radioactive decay, you would lose some protons, and so it would become a different element. But we don't care about that for us.
Okay.
For the most part.
Sorry.
No, that's okay. Parts of an atom. We will talk about that in maybe about 4 months. We'll talk about radioactive stuff, but not for now. So the parts of an atom, the middle is called the nucleus, the central core, and it's positively charged. So it's positively charged because it's made out of positively charged protons. So this is kind of nice. So you've got positive and proton both starting with the same thing. And then neutral.
Like, I know this, but I can't remember it because...
Well, it starts with this.
neutrons.
Neutrons, excellent. So that's kind of nice, but it's okay. P for positive and P for proton, and neutral for neutrons.
Next animation.
I wish electrons started with an N also. Oh, thank you. So electrons are found zipping around the outside of the nucleus. And what you need to know about that is that they are negatively charged. And I wish this started with a different letter, but it doesn't. So anyway, you have to memorize that electrons are negatively charged. They balance out the protons inside that are positively charged. So in a neutral atom, you'll have an equal number of protons and neutrons. So in a neutral atom, the number of protons equals the number of electrons. So protons, the number, I guess I'll write number like this. The number of protons equals the number of, that's a really bad number sign, the number of electrons. There. That's pathetic. Okay, ions. Ions are charged atoms or molecules. How do you think an atom would become charged, David?
Probably it gets like electrons.
Yeah.
Yeah.
It can't get protons because it would be a different.
Atom, so it gets
Yes.
extra electrons.
So smart. So the number of electrons is not equal to the number of protons. So for example, here's sodium. Sodium's got 11 protons, which means that it needs 11 electrons. So that's 1, 2, 3, 4. Let's count them out better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's got 11 protons and 11 electrons, so that means it's even. Here's the thing. It's not stable when it has only one electron in its outer shell. This is more than you need to know from my class, but an outer shell, at least for number 2 or number 3, should have 8. So what happens if you get rid of that electron? And
then it's
give
gonna
it
want another one.
Gonna want another one?
It's gonna bond with another.
Oh, well, yeah, but they don't need to know these kind of bonds.
Oh, okay, never mind.
So what happens to the charge if you've got 11 protons and you get rid of one of your electrons? How many electrons will you have if you send one
10.
away? You'll have 10. So that means you'll have 10 negatives and you'll have how many positives?
11 still, I think.
Yeah, exactly. So what will the charge, what the heck did I just write? 11? What would be the charge? Oh, it was supposed to be an 11. What would be the charge if you've got 11 pluses and 10 minuses?
The charge should be +1.
Good. So let's look over at that. So this one just lost an electron. It's got 11 positives, and it's got only 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's got only 10 negatives, so that's an overall charge of +1. So sodium's got a +1 charge typically. Let's look at chlorine. I'm going to go backwards for a minute. Here's the chlorine atom, and so that's got 17 protons, which means if it's neutral, it's going to have 17 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Good, it's got 17 electrons. Here's the problem. It would be more stable, and you'll learn about this in chemistry next year, but it would be more stable if it had 8 electrons. So it steals one from sodium. And so when that happens, it will have, let's go forward here, it will have, it still has, what was it, 17, right? It still has 17 pluses, but now it's gained this extra electron. So if you have an extra electron, instead of having 17 pluses, instead of having 18 minus it, did I just say that? Instead of having,
It's fine, it's early in the morning.
Instead of having 17 electrons, now it has 18 electrons. And what's the charge of an electron, Davy?
No negatives.
Negative. So if you have 17 pluses and 18 minuses, what's your overall charge? They balance each other out?
Negative 1.
-1. So that means chlorine has a negative charge. So these are ions. They are important because they are the electricity of the body. So if you've ever seen someone hooked up to an EKG machine, it measures the heart rate, and you're measuring the electricity of it measures the whole thing, the whole heartbeat. So this is the atria contracting, this is the ventricles contracting, and the ventricles relaxing. Whoops, here's the atria contracting, here are the ventricles contracting. Here's the ventricles relaxing. This bump is actually kind of close. So I'm not very good at reading these, but I can tell you the atria and then the ventricles are here. So this is the electricity that's happening in the heart. There's also, if you've ever seen someone hooked up to an EEG, you'll have an EEG if you have epilepsy or if you have any kind of possible brain disorder, and they want to check your electrical functioning in your brain. They'll do an EEG, and again, that's ions that are moving through neurons. So we'll do that when we get to the nervous system a little bit, and we'll talk about the ions that move around in your heart. So the electricity in wires is what in your house, David, to make a light go? What's moving? Do you know? It's some charged thing.
Yeah, it's an electrical. I don't know any technical
You
words,
don't?
but I think it just.
Well, guess.
I know it's
Electricity sounds a lot like electrons. It's electrons moving in wires. Not so in you. It's not electrons, it's ions.
Okay.
And what's the difference between an electron and an ion?
An ion is like particle, and an electron is not part of an atom or anything. It's just a
Okay.
little. It's not an atom. It's the thing spinning.
Right. So an ion is an atom that lost an electron or gained an electron, and an electron is just an electron, just one of those things. An ion could be a bigger molecule. It doesn't have to be just an atom, but it is. It's got at least one atom in it. It's good.
What is this?
It's chemistry, Ryan. Am I going to glitch out?
Yes.
Okay, this is a good place to stop, actually.
Behind the scenes, the real stuff that